Hey, hi everyone. Welcome to another video in our innovation frameworks series. This series we are talking about innovation, technology, and product management. Okay, we already discussed about TRIZ and QFT in the last two videos. So today's topic is we will discuss about how TRIZ and QFT can be used together to come up with product and technological innovation. Okay. So let's before starting that we'll just go through again TRIZ and QFT to refresh the concepts. So how to apply TRIZ for product and technological innovation step by step playbook. So first thing we need to do is we need to define the problem precisely. Write a functional statement what versus how. Separate the symptoms from the contradiction. So once you define the problem precisely, what versus how, then identify the contradictions. Contradictions could be like technical contradiction, improving A versus B, so increasing strength increases weight. Physical contradiction, some parameter needs opposite values in the same system, hot and cold at same place. Then transform these contradictions into TRIZ language. Map the problem to TRIZ standard parameters, 39 or to 40 engineering parameters we have. So this helps us to come up with the inventive principles. So consult this TRIZ matrix and inventive principles. For a given pair, the contradiction pair, okay, use this TRIZ contradiction matrix, which suggests 3 to 5 principles. Okay, use this principle to generate concepts, apply these suggested principles to brainstorm targeted ideas, and use some constraints like each idea must address that contradiction only. Then use substance field analysis, model the minimal system, substance A field, substance B, apply standard transformations to fix harmful or missing interactions, use resources and S curve, identify unused resources like material, shape, time, heat, software, assess the product life cycle S curve, and consider leap to next life cycle technologies. Choose some potential high potential ideas from them, prototype quickly. TRIZ helps generate more radical but implementable concepts. Then integrate this with the QFT and engineering. Translated selected TRIZ solutions into technical requirements and map them into QFT and prioritize the implementation. Evaluate them with 9 windows system. Consider effects on system at high, lower levels and across time. Okay. So that's step by step implementation of TRIZ. QFT. So QFT, we have already discussed about this, but like, we'll just go through it again. So what's are the customer requirements? They are prioritized by importance. Technical requirements of the house, which are engineering measures to meet those what's. Relationship matrix is there. Strength of relationship between what's and house. Strong, medium, weak relationships are maintained in this relationship matrix. Correlation roof captures positive or negative interactions between house and competitive assessment. We benchmark against our capabilities against competitor capabilities and weight scoring. Each factor or what or how will have a particular importance of each how will be there, which will give engineering focus. So that's the QFT. So now let's come to an example how we can use QFT plus TRIZ to come up with innovation. Example is urban electric scooter. So combined use of TRIZ plus QFT from US, UK, and India. Okay. So gather the customer requirements, which are the watts on a scale of 1 to 10. So first one is range per charge. The importance is 9. For US, it is highly important and useful for longer commutes. Price affordability, importance is 8. In India, price sensitive customers are there, so high sensitivity is there for price. Weatherproofing and durability, importance is 7, which is useful for UK. Wet weather is there. Portability and foldability is 7. UK multimodal commuters are there. Safety and lights, importance is 8. US and UK regulatory focus is there. Fast charging time, US India convenience is there. So these are all our customer requirements and the priority or importance on a scale. Watts, okay, we gather these watts. Then we come to the candidates technical requirements. House. So house are battery energy density, modular battery pack, okay, lightweight frame, IP rating, sealed components, integrated lighting, sensors, fast charging electronics, collapsible hinge design. Then we have a relationship matrix which maps the watts in the house. Okay, so range, price, weatherproof, portability, safety, and fast charger on the this side. The watts and house are battery density, swappable frame weight, IP, light sensors are on the top, and then there is the relationship strong, medium, weak is plotted in this matrix. Okay, Then we compute the importance of each how. Okay, so and then rank them by priority. So the most important when we do this is battery is swappable is the most important, then battery density, then frame weight. Okay, and then lights, fast charging, and go. And then we have IP seal and fold hinge. So based on this priority, then we will come up with an actionable plan. So top priorities is develop a swappable modular battery system. So to address this, this addresses affordability in India and range in US, and charging convenience, which also enables serviceability. So TRIZ linkage, applying TRIZ principles to this particular thing is principle 26, which is copying, and 7 is nesting. So modular cartridges and easy replacement, and principle 27, which is self-service for user replaceable packs. Okay. Next important thing is increase battery energy density A and reduce frame weight. So invest in composite structures and optimized frame geometry. TRIZ principles are 40 composite structures and 4 is asymmetry for geometry optimization. Next is safety electronics. E and fast charging capability or mid-tier investments. Waterproofing and fold hinge are important but lower priority. But combined consumer weighting still needed for UCAR customers. Okay, so that's how you apply. Once you come up with the top priorities from the QFD, then you apply the TRIS principles to come up with innovative solutions, like modular cartridges, easy replacement, composite structures, frame geometry optimization, etc. Okay. Country specific tailoring also could be done, like in India, focus on affordability, modular battery, user can buy cheap spare packs. So low cost manufacturing, rugged frame, easy maintenance. TRIS principles are cheap, 27, cheap disposable for low cost replaceable parts. 3, local quality to focus on durability where needed. USA, country specific tailoring is focus on range and safety, invest in high energy density cells and advanced sensors. Trust principles are 22, convert harm into benefit, regenerative braking into increased range, and 23, feedback for advanced driver assistance. UK, focus on portability and weatherproofing, folding design, high IP rating. Trust principles 15, dynamics for adjustable folding, and flexible shells for seals and coating. So that's how we can use TRIZ and QFD together. So you use the QFT to identify which technical parameters are most important. Then for those top technical contradictions, apply TRIZ. Okay, and TRIZ will give you some inventive principles how to solve those contradictions. So from those, you generate some candidate concepts from trace, and again rescore the QFT with new priorities and roadmap, and prototype and iterate. Okay, use trace to refine the concepts. So some short examples also we'll go through where we use TRIZ and QFT. So your smart thermostat QFT is energy saving, easy scheduling, and remote control. House are accurate temperature sensor, ML based control, voice assistant integration. TRIZ principles that we can apply are 28, replace mechanical with optical electronic. So use low cost MEMS sensors and cloud learning. Principle 23, feedback for adaptive control. QFD revise to invest in ML and sensor fusion. Okay, so UK all weather commuter bike is another example. So what is reliability in rain, low maintenance, foldability should be there. How TRIZ application is a flexible shells, principle 30 for seal bearings. Principle 15, dynamics for adjustable seat and handle. And principle 7, nesting for compact folding. India, a low cost water purifier for rural market. So low cost, low maintenance, high flow rate should be there. That's a QFT. TRIZ application is principle 3, local quality to allocate coarse filtration first. Principle 27, disposable to use low cost replaceable cartridges. Principle 36, phase transition to use solar pasteurization, heat based distinction as hybrid tech. So that's how we can use QFT and TRIZ together. And we went through some of the examples, urban electric vehicle and all-weather commuter bike, low-cost water purifier, smart thermostat, okay, where we can use TRIZ plus the QFT concepts to come up with innovative principles. Okay. Now let's see if we want to convert, have some session to run this together. Preparation work we need to do is we need to collect the voice of the customer and technical baseline, then bring patents and competitive information. Workshop structure should be 90 to 120 minutes. TRIZ to discuss on one contradiction and use this 3 to 5 TRIZ principles to generate some ideas, map them to QFT, and reprioritize. Tools we need to have a TRIZ contradiction matrix, 9 windows, board, substance fill templates, QFT spreadsheets. Metrics we can use is we can track the expected performance improvement, time to market, cost delta, and risk. Prototyping we can use to develop modular prototypes to test TRIZ inspired concepts. So that's the QFT plus TRIZ, how it can be used to come up with product and technological innovation. We went through a few examples also, like all weather commuter bike, low cost water purifier, and smart thermostats, and urban electric scooter. Uh, Thanks everyone. Have a nice day. Bye.